Hey guys, we're moving on today to something new. I hope you find it as interesting as I do. We're making our way slowly through infinite limits. What you should have finished up and submitted in your homework from Delta Math is your review of limits. So you kind of get the same concepts that we've been talking about, what's happening as we're approaching a number. And what we're going to do today is start to think about what happens not when we approach a number, but when we approach infinity. So what happens is our x value goes to positive or negative infinity. So that's what we're going to focus on today. Today we're going to be looking at graphs and tables. So if you have your TI-84, get that out and do this along with me. If you don't have a TI-84, I want to remind you that on Schoology, I have linked a free trial that you guys can use on your Chromebooks that will give you the emulator of the TI-84 that you can do with me. All right, so I'm going to make myself smaller and we're going to get into the notes. All right, not too small, of course. Put myself over here a little bit. All right, so we, just as a reminder, if you look through here what we did, this is what I did before. We talked about limits, approaching different numbers, end of lesson 1. So lesson 2, and remember I said it's your choice. You can print this out, you can just take notes yourself, and then at the end of the unit, I'll be having you upload all your notes onto Schoology. So we see these two graphs. Now I've given you these graphs. You'll notice on your homework that sometimes the graphs are given to you, sometimes they're not. So let's take a look at these two. If I was given this as a problem, like let's just say that I gave you x plus 2 over x squared plus x plus 1, okay? And we didn't have the graph with it, okay? It was just the equation. Our first course of action would be to plug things in, but here's where things are different. Now we're talking about infinity. We're not talking about a number. If I asked you what is this function approaching as I get close to 0, I would just plug 0 in and see what happens. Or if it was approaching something at 4, I would plug 4 in. And we'd use our methods from before to try to figure it out. But of course, we are approaching infinity. This is totally different. Now this, pointing out here, now that I've got my pen, let me use red here. We are approaching negative infinity. That means I want to see what is happening or what number is this function approaching as I go towards negative infinity in that direction. And you know, I'm not a big fan of saying what does it look like's happening, but you know, when we start this process out, we can kind of look at what it looks like it's approaching. And remember, limits, we're looking at what the y value is approaching. It's a little hard to see here, but it looks like it might be 0. You know, you can see the graph kind of go down like that, but it's kind of hard to see exactly and to think about what's going to happen as we go on into the way into the future. So I want to show you a few things on your calculator that you might find helpful. So let me pull up my calculator here. So even though I already have a graph here, I still want to look at my calculator and how my calculator is going to give me a table. It can be a lot more helpful. Okay, so I'm going to type this in. You can do this a few different ways. You can do your parentheses in the numerator denominator. You can use alpha y equals, remember, and it's going to bring this fraction drop down menu. I'm going to just use that and make this x plus 2. I think that's a plus. It's very small for my eyes. And this is going to be x squared plus x plus 1. All right, so there's my equation. If you're using your calculator and you're one of my stat kids, please go up and make sure your plots are not highlighted. So you might want to hit enter on it. If it would look like that, that would mean a plot is on. Turn that off. I don't know where you were at last time you used this, so I always recommend you go to your Zoom and use 6, which is your standard Zoom 6. And we should see something exactly like what we see on our paper, and I do see the same thing. I'm seeing the little hump in the middle. I'm seeing it kind of looks like it's getting close to that 0 number, but maybe it is slow. I can't really tell exactly. So I think the best way to figure this out is to look at the table. So if you haven't utilized table features in your calculator, it can be really helpful when you're solving any kind of problem that involves graphing or just solving equations, limits especially. So if you look, it's kind of hard to see on mine. So I'm going to make this a little bit bigger. And I'm going to show you my, okay, well, that's not what I meant to do, but whatever. There's one that'll give me the keystroke. Maybe that's it. No, that's not it. Well, we're going to just leave it at that then, but it's a little bigger so you can see it. But if you look right here, table set, it's right above window. So second table set, oops, that's window, second window. There are lots of different options in here. We have table start. Okay, so where do we want our table to start at? Where do we want to start at? Usually I'll start at 0, but it just depends. This is the important thing here, this little delta table. That means the change in the table. What interval do I want to go at? So maybe I just want to go by ones. And then you have the independent and dependent. Independent is your X variable. Dependent is your Y variable. You can either have it automatically come up, or when it says ask, it means I'm going to be the one that gets to put the number in. So I'm going to put it on auto just to kind of let you see what we're working with. Our table is second graph. And you'll kind of see, because of the way that I put this in, what's happening. So few things. If you look, I don't care that much about going to positive infinity. I'm going to negative infinity. But you see how when I go to positive infinity, look at my different numbers. Okay, so the bigger I get smaller and smaller and smaller and smaller numbers. Okay. Which is fine. Okay, but it's kind of hard to see with them as fractions. But as decimals or as fractions, they're getting smaller and smaller. So what I'm really interested in is what is happening as I'm going to negative infinity. So what's happening to my -1, -2, -3, -4? Am I still going to go to 0? What's happening? Okay, so you can see I've got -1/7, -2/13, -4/31. Wow. Okay, so they're small. I'm seeing that, but how small? Like, is it eventually going to reach a number? Is it going to be going back and forth between two different numbers? So one way that I like to use to kind of make it a little clearer is I'm going to go back to my table set. I can get it. There it is. And instead of having auto, I choose ask. Okay, so now when we go back in here, I get to pick my X value. So let's start. I mean, I see at 0, I'm going to get 2. I knew that was going to happen. Let's try -5. Oops, I put minus instead of negative. I'll fix that. -5, enter. Okay, -1/7. Let's get even bigger. So -10. Okay, that's an even smaller number. Let's do -100. Ooh, very small, but close to negative, or close to 0. Let's do -1,000. Or that's more than 1,000. That's 10,000. Let's just do 1,000. Uh-oh. Okay, so we're reaching the limits of our calculator now. This is a -1 e -3. That's -1 times 10 to the -3rd. So that's, what is that? 3 zeros and a 1 after the decimal place. Let's do even more. Let's go really big. Let's see what happens. Oh, it moved it over even more. How about even more? Okay, so we've reached the limit of my calculator. That is as small as it will go. And what I'm seeing in this trend is, as I suspected, this limit is 0. So the Y values are approaching 0 as I go further and further. Now, I know that seems like, why did I go through all that work? Well, I'm trying just to show you how this thing works. Maybe in the future, you won't have to type everything in. Okay, so this is approaching 0. As we approach negative infinity into the infinite that we'll never reach, eventually we are getting closer to 0. Okay, let's look at the other one. All right, so we had 3x cubed over 3x squared minus 2. Again, if we were approaching this previously, we would just look at it and say, hey, let's try plugging the number in. Well, plugging the number in isn't super helpful here because we're looking at negative infinity in this one. So what's happening is my Y value is approaching negative infinity. And this one's kind of cool how it happens. So, if we're going to start, on the right, so over here are our positive numbers. Well, first we see their Y values are getting lower. They're approaching this number, then it goes up here. But I'm interested in long term, as I'm going to negative infinity, what is happening to my function? What is happening to the Y values of my function? Okay, so this one, I think you can kind of see what's happening. It's certainly, my Y values are getting smaller. How small are they getting? Where are they approaching? What number are they approaching? So if I'm going to do this in my calculator again, let me make this small. Let's go back to my Y equals. Let's do this the other way. So not using the special function, the fraction function. So I'm going to just do parentheses. 3x cubed to the third, close those parentheses, divided by 3x squared minus 2, close parenthesis. Okay, let's take a look at the graph. We should see similar things here, except our graph over here is probably a little bit nicer than mine's going to be. Zoom 6 it. Okay, let's see. We see we've got an asymptote there. We've got an asymptote. It looks like it's at -1 and 1. Very similar looking graph. All right. I want to know, generally it looks the same. So let's go to our table and have that same conversation we had before. It's gonna, let me reset this to be, let's start at 0. And let's go back to auto, but let's make it jump by bigger numbers. So maybe like by 5s. Okay, so let's go back here and look at my table. Okay, so this a little bigger too for you. All right, so at 0, let's take a look what's happening as we go to positive infinity. Look at that. 5, 10, 15, see how it's getting bigger? Okay, let's look what's happening here. Oh, so we're getting smaller and smaller and smaller. We're increasing, we're going. Okay, so obviously looks like it's getting closer, like bigger and bigger negative number. So a smaller and smaller number. I don't know how you want to think about that. Let's look at our table if I ask it. So let me go back to ask and see what happens. And hopefully we'll see similar reactions to what we did with the last one. So second graph. All right, so let's start with -5. Okay, we kind of, oops, I did that again, darn it. -5. There you go. Let's do -10. Okay, that's no fun. Let's do bigger. Let's do -1,000. Well, that's fun. -1,000 gives us -1,000. I didn't know that was going to happen. 10,000. Interesting. Even, let's just do even more. Oh, interesting that this is happening. I wonder if we'll be able to investigate this mathematically. What we're going to find, this is -1 times 10 to the 6th. So that's -1, 6 zeros. That's a -1,000,000, if you didn't know that. Is approaching -1,000,000, which is interesting, the ratio at which it's approaching that we'll talk about. So it looks like we're approaching what one might call negative infinity. Now we got to have a little bit of a discussion. Well, I can't have a discussion because you're not here with me, but what is our answer going to be? Can we have something approach negative infinity? Let's think about that while I take a sip of coffee. So we have to think about what negative infinity is. Does it mean a number, okay? Or is it a concept? That's kind of what we have to think about. So infinity is really just a concept, an idea that we're going on and on forever. If we went on and on forever counting in the negative direction, we would never reach negative infinity. So basically, as mathematicians, even though it's approaching negative infinity, because negative infinity is not a number, it's a concept, we actually say that the limit does not exist, or DNE. Now, it is helpful to know that it is approaching negative infinity. When we give the actual answer of what the limit is, we write does not exist. Now, I know there are some people, professors, teachers who might, have you write negative infinity knowing that it's not really a number, so it really represents a concept. So it really doesn't exist, but we're writing negative infinity because we're just getting you to think about where this is going to. I choose to have you write does not exist because that's what I think is makes the most sense. But we'll talk a little bit more about that in the future. So I think that's it for today. Lesson 2, we're gonna get into a little bit more. Okay, what if I don't have a graph? I mean, you can always use the graph. You can always use the graph to look at it, but sometimes it's a little easier if you understand some of the rules. There's basically 3 rules that we're going to get into, and then we're going to get into really fun ones like, what if it's an exponential and you're going to infinity? Ooh, try not to get too excited. All right, I think that's it for today. We're working on Delta Math number 2, and this is just going to be basically looking at graphs and tables and helping you figure out what the limit is as it approaches infinity. That's it.